Hi, Jill. We're just getting started here. Hi, Mateo.
Hey. Okay, yes, that works better. I don't know what is.
Yeah, I'm not sure. I just you also.
Okay, so we should be able to see my screen, right?
Yes. We might want to just give it a minute for people.
Yeah.
Mateo, do you want to just go ahead and get started? I'll introduce you and then we'll jump.
Sure, yes.
People can join. Okay.
Thank you.
Well, welcome everybody to our monthly project updates. Mateo Merli is our CTO and he will be presenting these to you this month. So welcome, Mateo, take it away.
Thank you, Don. So yeah, it's been a busy month this June, like May, June. So there is a lot of updates here. I try to summarize a bit because like we have been having a lot of new changes coming in and releases, a lot of work on the new releases. So I try to summarize in a bit like concise form. Before jumping into the updates, I just like a couple of reminder here. So there is the Pulsar Summit next week. So I haven't updated my slides here. So it's not next month now, it's next week, June 16 and 17. If you haven't registered yet, please go to the NA 2021 Pulsar Summit, and you can see like all the agenda. And we also have announced the keynotes. So they're public. There are keynotes from StreamNative, but also from Splunk, Verberica, Narva, and Micro Focus. There will be like a very interesting set of keynotes, and also the talks as well. So please go check the website and register. It is next week. I also announced this last month, but so we did the hackathon on last month, May, and we did the voting on all the hacks. I wasn't in the committee, so this really was like a very wide variety of submissions and ideas, and I say almost all of them were like very interesting. So the winners will be announced at the Pulsar Summit. So I suggest to check it out, because there were like really a wide range of ideas, like from improving some of the aspects on the metadata to improving the operability, or like some more like use cases on how could you use Pulsar to do X, Y, and Z. And it really was like a very refreshing and interesting. So I'm looking forward to see like when the winners get announced. So please follow that at the Pulsar Summit next week. So this month releases. So most of the work was in the Pulsar 2.8. We hoped to get this a bit earlier, but like we really want to make sure that everything was correct and in place and working as expected. So there's been a bit of delay. Try to get last minute fixes on a few issues. We had to cancel one of the votes because there was some regression when using rootless container. So we had to revert a couple of changes there, but we hope that by the end of this week we have a release announced out. We also had a patch release for 2.6.4. So this we backported one of the fixes for one of the CVE. There was a security issue that was already fixed in 2.7.1, so it had been fixed a while ago, but we didn't have a patch release for 2.6. So this is like mainly to get these security fixes to the 2.6 branch. So for people who have not yet upgraded to 2.7. And that also kind of like sparked the discussion. So since we don't have like a policy at this point to see like which versions are a user can expect to have security fixes, which version can user expect to be supported with the bug fixes and so on. So we are like kind of like working to formalize a policy there that would be set the expectation on what the duration. Let's say that if we release 2.7 or let's say 2.8 this week, how long will be get supported for bug fixes, the 2.8 branch, and how long will be supported for security fixes. So that will also help a user to understand the life cycle of these releases, and we hope that will be helpful there. So yeah, so we started like these backporting CVEs, and also like the idea is also to have like CVEs for dependencies to be included into these kind of like security supported versions. And that's also like sparked discussion of having LTS or like long-term support releases. That is still something that we are evaluating whether it makes sense at this point or will it make sense in some time. So yeah, more announcement will be done probably next month, hopefully, so that we have like a clear policy that set the expectations around the board. Continuing on this, so a reminder, so that these are kind of like the highlights for the 2.8 release. So we have the transaction support, which is finally GA. It was in preview in 2.7, also in 2.6 there was some initial support, but they were like it was mostly like preview for people to play out. Right now it is production quality, so we encourage anyone to try it out, and we expect it to be like a smooth sail there. There is also support for exclusive producer. We've been talking about a bit in the past, but I'm doing also like a talk at the Process Summit precisely on the exclusive producer. So if you're interested in this aspect, please follow the full talk. I will go through the whole explanation on why it is useful and how you can use it, and but also like a bit more like a deep dive on how it is implemented. That's more like not something that a user needs to know, but it might be interesting to know. So in 2.8 we also have the package management service. This was basically improvement on how the functions code gets submitted to a cluster. It includes things like versioning or like referring to the same package for multiple instances of the functions. So it's a much needed refactoring on how we store the code in the cluster and how we reference this code, these jars that are submitted to a cluster. Client memory limit. This is like a set of changes. There was a PEEP for that. I don't remember the number, but it is basically, we want to give control in terms of how much memory a client instance can be using, so that an application can have a much better and much easier configuration. So you don't want to go around and configure like your producer queue sizes based on messages, because that doesn't reflect the amount of memory that can be used in the worst case, or like if you have many partitions, that could increase. So setting the memory limit in the client itself, it makes it much easier to just say I want to use at most 64 megabytes, and the client will play within that boundary, and there are no surprises there. We have this pluggable metadata interface. So this is like again work in progress. And some parts of it are in the 2.8 release. Some components have been already migrated. Not all of them are migrated. The goal is to finish up for 2.9 release, but some part of it are already moving. And again, this will not be very useful at this point, but it will be useful in 2.9 once we have all components migrated, and then we can add more implementation for these interfaces and have different data stores. The broker metadata. So this is a support that at this point, the main use for this is a KOP, the Kafka Pulsar component, the protocol handler. And the reason for having these broker handler metadata is that we need to add some metadata when the message gets published. So some metadata gets appended to the message payload set by the broker when it gets published. And this is needed for having basically emulating the Kafka offsets, so that we can easily have support in the Kafka clients. There's the streaming dispatcher. So this is a different a pluggable dispatcher that can be enabled there, and the aim of this is to increase the throughput. So this is kind of like a new addition. You can try that, and it should be increasing the throughput, especially when you have multiple topics, and you want to basically make sure that the dispatcher, it is reading from bookies before it is at the same time that the client asks for data. So we have this flow control mechanism between the client, the consumers, and the broker. in the default dispatcher, the reading from brokers to bookies are not streamed, they are batched. So basically, there is only one batch in flight. With this change, there will be there can be multiple read operations in flight. So the broker will ask for more batches of reading, to read more batches at the same time from bookies, and to increase the read throughput. And one of the good addition in having more transparency of what policies are is that you can ask the broker what are the applied policy for a topic. So right now there are different ways that you can configure the policies and at different levels. So you can have like system defaults, you can have some overrides that happen in ZooKeeper. You can override specifically some of the policies, but also you have namespace level policies and topic level policies. So it was a bit difficult for a user to understand, okay, these settings, where is this coming from? Is it coming from namespace policy? Is it coming from topic level policy? So having the, and also like it was difficult to know which version was applied for this topic. So having this, you can check what are the effective applied policies for a particular topic. And one of the changes in Pulsar 2.8 is also the BookKeeper. So we have updated the version of BookKeeper to 4.14.1. That has been released last week. So that we were really also waiting for this release to release Pulsar 2.8. And there are like several improvements and many fixes here. So I will just go through some of them because there are I think that some of them are very interesting and that they open up a few different possibilities in Pulsar as well. So first of all, like one of the tricky parts that we had in configuring bookies was to set correctly the memory sizes, and that typically like requires like a bit of knowledge on how things worked and also on the workload. So in some cases, the suggestion was that, okay, just give it a lot of memory and everything was fine. And that is typically true. But if you're like in a constrained environment, you want to set like a lower limits on the direct memory or the, and then things you have to basically be more careful on these memory settings and on the workload. So in some cases, there was the possibility of getting auto memory errors, and that's not nice on the bookie. So I think we improved a lot on this front. So there are like few changes that are there. The first one is like on the bookie journal, there was a memory limit, but it was based on entries and the number of entries instead of bytes. So what happens there is that if you try to write much faster than a bookie can handle, and at the same time you're using very large entries, or if you're using multiple journals, that was another problem. Like you can configure a bookie to use multiple journals directory. So each directory is independent, but then each directory was like using the same 10,000 messages outstanding limit on the journals. If you have big entries, they say that 1 megabyte, then it's very easy to get out memory. So instead of that, we have basically a bookie-wide memory limit that also works if you have multiple journals, and that means that if you're trying to write even bigger, very big entries faster than the bookies can write on the journal, the system will auto throttle, and basically it will just like push back and add back pressure, and the bookie will not get auto memory. Another aspect is on the read. So we basically like so we use Netty throughout the Pulsar brokers and bookies, and the issue on the read path was mostly that we typically do the reads on a thread pool. So the writes, we do that writes from the netty IO thread, because that's not a blocking call. Only the journal is blocking, and the journal has its own thread. But on the read, we have a thread pool just for read operation. And typically, like, you will either read from disk or read from the read ahead cache. And once you have this buffer is reference counted, and we write on the socket to push it to brokers. Now, what happens is that if the brokers are slow, for example, or like if there is any network saturation, this buffer will not be released until they can be written on the socket. That means that there was an amount of memory just like on how we write on these sockets, and that this TCP window is writable or not. So instead, like, we try to basically do this auto throttling, so that we don't have. If we try to write on the connection on the socket, and this operation is blocking, we basically want to also have back pressure on the read. So we stop doing the reads if we cannot write those read results on the connection back to the BookKeeper client and in the broker. So again, the journal one was on the right side, this is on the read side, but we basically like really control the amount of memories to make sure that we don't exceed any limits. Another one that was also fixed. So this would be basically like, there was like an issue with like trashing the cache of bookies. If you have like a very low amount of memory in the configure in the bookies, and you have a lot of readers, and the entries are big, that basically like what would happen is that we have these read ahead concept that really works well if you have like a big cache. And if the cache is tiny and you have big entries, and you try to basically to prefetch everything, basically fill the cache back again. So each reader will basically step on each other and basically cycle through the cache and use it everything. So we kind of like improve there so that this trashing will not happen. Finally, there was like other changes that the RoxyB block cache that is used like to cache the RoxyB indexes. It was set to 10% of their memory, but the problem was that the config file was using a 256 megs, but also that the size was also applied directly. So if you had multiple directories, it will use 10% each instead of like 10% overall for the bookie. So that was also fixed. So this should bring the memory usage of the bookies to a same level, like without even like configuring a tiny amount of memory on the bookie. That should not incur in any OM errors.
Matteo, you have a
Yes.
question in the chat?
Yes.
Okay.
Let me see if, because I'm full screen, so I'm trying to see. Trying to get to the chat. Second. Okay, now I can see. So which one? Okay, so right now the Pulsar standalone can only be launched with one bookie. Pulsar standalone done bookies 2 causes an out-of-memory error. Sounds like this problem should be fixed in 2.8. I'm not aware of this. Now, I don't think we have any fix for it in the 2.8.0 tag, but it might be fixed in 2.8.1 tag. My question here is more like, why do you need 2 bookies on the standalone? Because they're on the same node. So there is no really a big advantage of having 2 copies on the same disk of the data. So it doesn't give you more availability. It doesn't give you more reliability because all the data is on the same disk anyway. So I'm curious of what's the reason for using more than one bookie on a standalone node? So if you can update the question, I'll try to answer.
I can also unmute him as well.
Okay. Yeah, sure.
Oh, can I talk?
Yes, please.
Okay, so it's because when I launch the broker through IntelliJ, the broker requires 2 or more bookies. Otherwise, I can only use non-persistent topics when I use the broker through IntelliJ.
I see. So you're starting as a standalone, but you want to spin up a broker independently from that.
I'm trying to debug broker code. So I start up a standalone cluster with no brokers, and then I start the broker in IntelliJ. So I am able to debug it. But the broker says something along the lines of there has to be 2 or more bookies, but I can only get 1 to start. Yeah,
sure. That's because like when you deploy a broker in non-standalone mode, the default replication factor is 2. So you can change that by configuring 1 copy in the broker.conf that by default. So it is like managed ledger default ensemble size 1, default write quorum 1, default act quorum is 1, so that it will only attempt to use 1 bookie.
Oh, so there's a config line on quorum size for bookies for broker.conf.
Yes.
Okay, I'll try that. Okay, thank you.
Okay.
You can mute me now. Yeah, that was my question. Yeah.
No worry. So, okay, so this basically like we just got given a glance of fixes that we did to make sure that we don't get OM errors in bookies. There were like also like other interesting fixes here in the bookies. For example, like there was these were like most like potential issues that were not like seen in practice, but they were like discovered through a TLA plus model. So one of the ex-colleague of us basically has created a TLA plus model of BookKeeper protocol, and with that, some issues during the recovery were discovered. In the specific, there could be like an ensemble change during the ledger recovery could make some entities to disappear. That was fixed. Again, this is not something that we think is easy to reproduce in the practice, because there has to be like a lot of coincidental thing that happens at the same time. So we haven't seen that in practice in many years, but that's something that was there in the protocol, and now it is fixed. Another one was that in the recoveries, for some reason, that was the fencing was not getting applied, and that also could potentially lead to a data loss, because that when the last entry for a ledger gets established, that could mean that it gets established at a lower level. So that is also fixed, and again, that was also something that was discovered through this theoretical model of the protocol. Another aspect is the table service. So table service is a key value store that is part of the BookKeeper project, and it's essentially like a distributed key value store that is implemented on top of BookKeeper and RocksDB. The main usage of table service at this point is the functions state store, so that from a Pulsar function you can set state or get state, or like from a Pulsar connector you can do that as well. So, and there's been a lot of improvement in 4.14 on the like reliability and I mean, yes, overall reliability of the table service component, and so that they can be really used in production. So it is used in production in many places at this point, because it is really maturing. So Pulsar 2.8 will be in a much better place for respect to the state storage, because of this improvement in BookKeeper for 14. And now, like, I'm switching gears a bit. So these were like all changes that were in that are, I think that are very relevant for Pulsar users that were in BookKeeper 14, that will be included in Pulsar 2.8. But if you look at the last month worth of changes, I said there have been a lot of work for the release, and I kind of like fit all the features and bug fixes here, but I will just go through a small selection of it. Namely that, so one of the changes was on the, okay, yes, this was skipping this one. We switched from the ZooKeeper metrics from having a custom provider to using the ZooKeeper Prometheus metric provider. So in like a few years ago, like we were trying to add metrics to ZooKeeper, and ZooKeeper was really very poor on the aspect of metrics in the past. There was like no easy way to get metrics out of ZooKeeper, and ZooKeeper itself was not collecting a good set of metrics. They didn't have any like a rate of like requests or like latency, where basically an accumulation and average since the ZooKeeper service was started. So it was really like a very bad set of metrics, and it was not easy to read them out as well. So at that point, we tried to went down a route that was we used AspetJ to inject code into the ZooKeeper. Like it's a bit, sounds a bit hacky. It is hacky, but it worked. It was a bit like intermingled with the ZooKeeper internals, but we were able to basically add our code within the ZooKeeper code without basically forking ZooKeeper. And what that enabled us was is that we could inject these collection points. So we could collect the metrics for latency on the client side and also on the ZooKeeper server side, and have different metrics for like write operations, latency for write operation, for read operation. We could add like which is this like a set data or like a create a Z node and so on. Basically like having this rich dashboard on the for ZooKeeper operations. At this point with ZooKeeper 3.6, ZooKeeper supports a pluggable metric systems. So it does not make sense for us to continue to do our hacky stuff. There is an officially supported Prometheus implementation of that metrics interface. So instead of like relying on AspetJ, we just removed all our custom stuff, and instead we just use the ZooKeeper metrics. And one additional reason for getting rid of AspetJ is that it doesn't work on Java 16. So and doesn't look like that is getting updated to be working there. So it's every Java releases, AspetJ was like striking a bit several months behind before it was working there. So we just like removed one additional point of pain there, and we have the same set of metrics. So we have changed the dashboards also for the on Helm charts, so that when you deploy Pulsar 2.8, it will by default use these new set of dashboards and for ZooKeeper metrics. I think there's one more question.
Yeah.
Okay, we use Pulsar standalone. We have repeatedly run into this error field to restore RocksDB. We are using Pulsar 2.7.2. Is that a problem fixed in Pulsar 2.8? On top of my mind, I'm not sure what is this problem, or why it's failing to restore RocksDB, but I think there were like fixes on the if that gets corrupted, if that file gets corrupted, and I think that there were also issues in RocksDB itself that were fixed. So the version of RocksDB now is a newer one, but also like if that fails, if that RocksDB file gets corrupted on the disk, that will it is something that table service is able to detect and avoid at this point by refetching that from BookKeeper. So I don't know the specific error, but I think that there are several fixes on how RocksDB files are loaded and handled. So that possibly should fix that, if it makes sense. Okay, so back on ZooKeeper, yeah. So the dashboard has been updated, and we could get rid of this tech debt at this point. Another one interesting for StreamPass user is that there is now a way to configure like a file logger factory, so that by default, the StreamPass client, when you compile it, we don't compile with log4cxx, although it is possible to compile with log4cxx. And the reason for that we don't do it automatically is that log4cxx brings in a ton of dependencies, like from the Apache API runtime and several others. So that is, we didn't want to have everyone to compile these dependencies, because in every environment is can be very tricky to compile the full set of dependencies. So we used to provide like just like write on console, and also like the ability of setting your own logger through an interface. But instead, like now you can just configure the file logger and say specify the file name and the log level, and all the process CPP logs will go to that file. So it's a simple log to file, but it's kind of like something that can be useful for many of the StreamPass users. On the schema side, there was one interesting change. So this is really useful if you're like using the generic object, this auto schema detection. And what enables you is that you can consume from a topic that has a schema. And this topic can also have multiple versions of the schema with different fields, for example. And you really want to be able to detect what that schema is. So with this, for each message, basically there is a new method gets read a schema, and that will give you the access to the schema of that particular message, not for the just for the consumer or the reader, but for this message. So if message one message to have different schemas, when you try to access that schema, you will get the exact schema that this message was created with, and that really helps if you're like doing a generic processing that uses the schema. For example, like if you're writing a database sync, for example, you can use this and to set all the fields correctly based on the and discover automatically the fields of the message without knowing that, without having access to the Java module or like the protobuf object. So this is really like more like doing the runtime discovery of schema for each particular message. Yeah, I mentioned that. So this is useful on the Pulsar.io. There are other changes in Pulsar.io. So this one also is a kind of like interesting, because there is basically that's been added a compatibility layer that makes sure that you can use now any Kafka Connect sync and run it on Pulsar.io. So there is this compatibility layer for the Kafka Connect API on the syncs, and you can basically have new things with the and submit it with the using that base layer, and anything should be just working natively on Pulsar.io. So you have the Kafka Connect code and just running on Pulsar.io, reading from Pulsar without any other change. So yeah, if you have any system that you don't have the Pulsar.io sync, you can just reuse any Kafka Connect sync adapter without any code changes. This one is again, I think I think this is very interesting. I'm very interested in performance and how to measure and have it like low latency. There's a way to configure the low latency path, low latency on the data path for Pulsar right now. So this is like a new in 2.8. Essentially, what that means is that to achieve low latency, you have to get rid of all the context switches at all the steps. So from the producer to the broker, the data path will then go from broker to the bookies and back. Like the acknowledgement path also need to be low latency, so that the acknowledgement from the bookies to the broker and the acknowledgement from brokers to the client has to be low latency. What that means is that we want to avoid any context switch and not paying the cost for context switches on any of these legs from data and the ACK path. And the trade-off here is that we basically like consume CPU. So it is not like a general use approach. The trade-off here is that basically we are like consuming CPU in order to save latency. And this is like, of course, this is not something that can be done by default. Only for a specific set of use cases it will make sense. If you do this busy wait approach, essentially we change that through all the native IO thread and also like all the internal BookKeeper and Pulsar worker threads. They will instead of like going to sleep when they're done with something, they will basically keep polling for new work with some backup strategy, but essentially you want to make sure that the thread never sleeps. And because if the thread sleeps, the OS will deschedule the thread, and then by the moment it gets rescheduled on the CPU, it will be like say tens of milliseconds at the very least. So that is a very high latency. Instead, like everything keeps going on. And we also have this, when you enable this busy wait flag, it is doing a bunch of stuff under the hood automatically. So first of all, it just works on Linux, and it's assuming that you can get control of CPU. And the reason for it is that we're doing this CPU affinity. So we are basically pegging the threads that are used in the data path. We are pegging them to one CPU core. So a thread gets assigned to one CPU core, and that CPU core is reserved for this thread. Also, yeah, so we're using this affinity that is done automatically. And also we disable hyperthreading on the cores, because hyperthreading gives more throughput, but it's basically adds noise on the core, and therefore, like if you have two threads sharing the same core with hyperthreading, you will see like basically latency bumps when one thread gets ahead of the other on the core. So because some of the resources in the core are shared across the two threads essentially. So with all these changes, the idea is that you are able to consume CPU, but gain low latency, and we've seen that is able to we are able to get end-to-end latency in the order of 100 microseconds. So this is like a really low latency compared to the normal Pulsar deployment or any other messaging system deployment. So 100 micros end-to-end from producer to broker bookies and to consumer. Okay, that's, oops. Okay, there's a follow-up question. When I start, when I launch the Pulsar Broker Starter in TGI, not enough bookies. Yeah, so it is not broker.conf. So if you're, yeah, so it is reading from you have to pass that config file to the broker starter. That's you have to use a dash conf and pass the correct config file. Otherwise, it will pick the default value, which is to use to replication factor of 2. Yeah. Okay. Let me go back. Okay, so this is for low latency. We will publish more about this. But this is like very exciting way to get like a very low latency by just changing a few flags in the deployment process. Finally, so we have been talking about this metadata data store and Blackboard metadata store for a while. There's been a lot of work, so it is continuing. And we've been basically in the process of migrating all the key components of Pulsar to use the metadata store interface, namely the namespace service, which is the one that is used to handle like all the namespace policies and assignments and so on. So this is already migrated. Also, like the managed ledger factory is already going through metadata store. Again, that's one piece at a time. We also have added this additional feature that basically when we do leader election, so there's a leader election component in the data store, and it is now able to revalidate the leader election and the logs after we lose a Zookeeper session. And the purpose of that exercise is that we want to be able to that the survey should be able to survive the loss of the Zookeeper session. So if we lose a Zookeeper session, we have to reconnect and revalidate to make sure that anything that we own, like all these locks and leader election state, has to be resynced to what Zookeeper has, and we may have to recreate it if it is not there, or we have to either like reacquire or give up if we're not the owners anymore. So there's a lot of moving pieces there, but all this logic has been packaged into this leader election component. Also, yeah, the load manager has been also migrated, and also like the initial setup of the Pulsar cluster also goes through metadata store. So there's a lot of work, and it's continuing, and it's still on track for 2.9 to have all this work completed here. Okay, so I'm done with updates. Again, this is like just a subset of what happened. It's just like just to give a glance. If you're interested in more fine-grained updates, there is the weekly newsletter that goes that gets published, and that goes for more in detail about the bug fixes and new features that gets implemented on every week. So typically we have the office hours on the next week, but next week is the June 16. We have the Pulsar Summit, so there's a conflict. So the next Pulsar office hour will be on July 14th instead. So just our changing schedule for this month, but typically, like then we go back to the regular schedule in which we have this monthly project update, which is on every second Wednesday of the month, and the office hours are on the third Wednesday, always at 12 p.m. Pacific time, and the intro to Pulsar is on every fourth Wednesday. So just next week that the office hours will not be there. And with this, I'm concluding this session for this month. And if you have any question, please feel free to ask.
I have unmuted everyone if you would like to talk.
Okay, so if no questions, then we can close it. You can always reach out to me and on Slack or by email and ask questions.
Oh, I do have one more question if no one else has a question.
Sure, go ahead.
So some time ago, I filed a ticket for the Python client library on improving its support for Avro schemas.
Mm-hmm.
Are there any plans to address that in an upcoming Pulsar release?
Yes, we need to go back to that. I will. I said I will last time, but we were really kind of busy with the 2.8 release. That really sucked all the time and efforts. So I think that we should go back to it and include that in 2.8.1 release.
Oh, perfect. Okay, that's awesome. Yeah.
Yeah.
Thank you.
Thank you. Okay. Thank you, everyone, and bye.
Thank you.